Welcome back to rational functions, graphing rational functions, finding their asymptotes, and all of the properties about them. We're going to continue on with the notes here, so we're jumping down to example number 3. You've already completed the information in the previous part of this video, which was lesson 2.6, 2.7, part A. So if you need to take some time to review that, feel free to go ahead and take some time to review that. On your handout prior to example number 3, you're going to see some guidelines for graphing rational functions. Please feel free to read through those for your own personal review. All right, so what you will notice is that all of the graphs that we're going to make right now are actually the problems that you just did in part A, where you found all of the vertical asymptotes, horizontal asymptotes, and or slant asymptotes. So we have that information already. You can look back at your work from those problems, and then we're going to start with that, and then we're going to continue to build with these rational functions and continue to make the graphs. All right, so problem number 3. We are going to be graphing this x squared minus 16 all over x plus 4. So from the previous part of this lesson, we first started by factoring this, and then we ended up with x plus 4 times the quantity x minus 4 all over x plus 4. And then we said, well, that means that we can cancel this x plus 4. And so if we go ahead and we cancel the x plus 4, all that we're left with is f of x is equal to x minus 4. But because we canceled the x plus 4, we said that we also have a hole. And so let's talk about how we actually find that hole. So in this class, I would like you to write the hole as a coordinate point, not just write x equals. So you take the factor that canceled. So the factor that canceled is x plus 4. We set that equal to 0, and that tells us that the x coordinate of the hole is x equals negative 4. And then what you do to find the y coordinate, you take what's remaining. So we take the f of x that's remaining, and we calculate f of negative 4. So that would be negative 4 minus 4. So that gives us negative 8. So that means that we have a hole at negative 4 comma negative 8. So point discontinuity is what we call a hole. So that's at negative 4, negative 8. Also, because the factor canceled and we ended up with our equation simply being f of x equals x minus 4, which is just a line with a hole in it, we do not have any vertical asymptotes or horizontal asymptotes. So here we're just graphing our line. F of x is equal to x minus 4. Change the color of my line here. I'm going to make it purple. I can go ahead and start by just graphing that. I know that my y-intercept is negative 4. And my slope is 1, so rise 1, run 1, rise 1, run 1, rise 1, run 1. But I know I have a hole at negative 4, negative 8, so I'm going to go ahead and put an open circle right there. And that flows with my line that I have. And then I'm going to go ahead and connect that to make my line. Don't forget, when you make your line, you're always going to put arrows on it. Arrows, and in the other direction, arrows. And then we'll go ahead and we'll fill in all the rest of the information that is in our problem here. So we're asked to find the x-intercept. So the x-intercept is going to be 4, 0. The y-intercept is 0, negative 4. We said there were no asymptotes. We have our point discontinuity, which is our hole at negative 4, negative 8. And then the domain. I'm going to write the domain today in set notation. X such that x does not equal negative 4. And then also the range is y such that y does not equal negative 8. Because that hole is at negative 4, negative 8. All right, let's continue on. Oh, lastly, label at least 3 points on your graph. Since we just have a line, we only just pick any 3 points. So negative 3, negative 7, I could, 0, negative 4, and 2, negative 2. Any 3 points would be perfectly fine for this line. All right, let's continue on. We're going to skip some that you guys are going to go back and continue or finish on your own. And so here's our guidelines for graphing below this problem. All right, so here's our guidelines for graphing here. So you can read through those to get more information about what we just did. You're going to do number 4 on your own. You can see I already filled in the asymptotes because we already did that. Number 5, you're also going to do on your own. And again, the asymptotes, we already know that because they are from the previous problems from part A. Number 6, you guys are going to do on your own. And then we're going to jump to number 7 to do together. Sorry that number 7 runs into number 8, but we're going to have to just work with that. So number 7 here, again, we can see that this function that we have, f of x, We already found the vertical asymptote in the part A of this lesson to be x equals 6, and we found the horizontal asymptote to be y equals 1. We also notice when we found that we first simplified to get x minus 3 times the quantity of x plus 1 all over x minus 6 times the quantity of x plus 1. So we did cancel a factor of x plus 1. So that means that we have a whole at x plus 1 equals 0, so x equals negative 1. Then the remaining part of the function that we would want to find is we want to find f of negative 1 with what's remaining, which is just the x minus 3, so negative 1 minus 3 over negative 1 minus 6. And so that's going to give us negative 4 over negative 7, so we just have 4/7. So our whole is at negative 1 comma 4/7. Or our point discontinuity is the more formal way to say it. Whole at negative 1 comma 4/7. I'm going to go ahead and I'm going to put that on my graph right away. So negative 1 comma 4/7, somewhere right about here. And we're going to label it negative 1 comma 4/7. And this can count as one of your labeled values as well. All right. And so then I need to find 3 more points on each to the left and to the right of my vertical asymptote. So I can go ahead and calculate points, but before I do that, I might as well find my intercepts because those can count as some of my points. So if I find the x-intercept, to find the x-intercept, then I'm going to let the y-coordinate equal 0. So letting the y-coordinate equal 0, I can see that my x-intercept is going to be at 3, 0. 3, 0. My y-intercept, I'm going to let the x value equal 0. So for my y-intercept, I end up with 0, 1/2. And of course, you can show the work for this. I'm just not going to show it because I know that you guys can do that. All right, so I'm going to graph those 2 points. So I have 3, 0. And when I plot it, I want to label it in 0, 1/2. So 0, 1/2 right here. All right, and so this is going to be my left branch for my graph. So here I have my left branch and approaching my asymptote there. And then the right branch for my graph, I can find some points over there. So if I plug in 7, let's see, if I plug in 7 and I calculate, remember when you're calculating, what's remaining of your function after you simplified is simply x minus 3 over x minus 6. And so I'm just plugging 7 in there. So then f of 7 is simply 7 minus 3 over 7 minus 6. And so that's going to give me 4. So I have 7, 4. If I go ahead and plug in 8, so f of 8 is going to give me 5 over 2. So 8, 5/2. And go ahead and plug in 9 and see what you get for 9. And when you plug in 9, you're going to get 9, 2. And so there is our second branch of our graph. And then lastly, we want to talk about the domain and the range. The key with the domain and the range is don't forget about the whole. That's a common mistake. So don't forget the whole. All right, so if we need to remove the vertical asymptote, we need to also remove the whole for the x coordinates. So my domain is going to be, I'll squeeze it in here, x such that x cannot equal -1 and x cannot equal 6. My range is going to be y such that y cannot equal 4/7 and y cannot equal 1. All right. There's number 7. Next, we're going to do number 8 together. For number 8, you are going to need to also use your graphing calculator. So you can go ahead and grab your graphing calculator out so you have it ready to go. And again, I apologize that number 8 is running into the graph above, but we can work with it. All right. So for number 8, when we calculate this problem here, we again already found the vertical asymptotes and the horizontal, or actually in this case, a slant asymptote from the part A video. So let's go ahead and find the x-intercept. So to find the x-intercept, then what I'm going to do is I'm just going to let my y equal 0. So letting y equal 0, really, what I'm going to do is just have 0 equals 3x squared minus 2x all over x minus 3. So it ends up being whatever makes the numerator 0, and I'll factor an x out of that right away. So I'm going to get x times the quantity of 3x minus 2. So that means I get x equals 0 or x equals 2/3. So my two x-intercepts, so I have 0, 0, and then I also have 2/3, 0. And I can go ahead and place those on my graph right away. So 0, 0, and 2/3, 0. All right, so I have 2 points already in that region, so that's good. Finding my y-intercept, well, my x-intercept is 0, 0, so my y-intercept is going to be the same, 0, 0. We can only have one y-intercept because it has to be a function. All right, and so now I'm ready to make my graph. Now, so I know that my graph is going to be approaching the asymptotes, and I have these 2 points here, so my graph is going to be coming up from the bottom somewhere like this, and going through those 2 points and then approaching the asymptote to the right. And then my other piece of my graph is going to be up in the top right-hand corner. Scoot that down a little bit. So up in the top right-hand corner, I'm going to have something that's going to be like this. And I know it goes way off my graph, but we'll just work with it right now. All right. And so what I want you guys to use the graphing calculator for is I want you to use the graphing calculator to find the relative max and the relative min. At this time, we don't know how to find relative max and relative min without using the graphing calculator. So go ahead and open up your graphing calculator and type the function into your y equals. So here I have my y equals. And so I already have my function in there, 3x squared minus 2x, all divided by x minus 3. And then I'm going to graph that. Right now I just have a standard window, so that's -10 to 10 on both the x and the y-axis. Well, I can see that I cannot see the upper branch. I can only see the lower branch of the graph. So let's go ahead and change our window settings. So we'll make it what is, well, what's shown on the paper is not going to be enough either. So let's go from our x minimum. We really only need to go from like -4. So maybe -4 to, let's go to 9. And then on our y-axis, let's go from, let's just go from, yeah, -8 is probably good. And then let's go up to, 45. And maybe if you want to change your y scale to count by 5s, you can do that. And now we graph. And so we can see this is stretched out a little bit differently than what we see on our papers, but that's because we changed our window on our graphing calculator. All right, so now I want to find the maximum value and the minimum value. So in order to find the maximum value, I'm going to do second, and then I press the calc button, and then I choose maximum. And then I want my left bound and my right bound. Well, my maximum is on my left-hand side of this graph. And so I know that it's going to be somewhere between 0 and 2/3 because those are my two x-intercepts. So I could arrow over and move the cursor, but I don't want to have to just keep clicking. So the other thing I can do is I can just type in what I want my left bound to be. So I want my left bound to be 0, enter. My right bound, well, I know it's again somewhere between 0 and 2/3. So I'm just going to type in 2/3 for my right bound, enter. You don't have to guess, you can if you want to, and then you're going to see your relative maximum. And so now you're going to take this from your calculator and then you're just going to label it on your graph so that our relative max, I'm going to put a little arrow, is 0.35. 0.35 over onto the nearest hundredth, that's fine. Was my y-coordinate was 0.13. And that's the relative max. We're going to need this so that we can find our range for our function. Similarly, you're going to do the same thing for the relative minimum. So second calc, and now we want minimum value. And our minimum value is going to be somewhere to the right of the asymptote. So I'll just put like 3.1 because I know my asymptote's at x equals 3. And it looks like maybe it'll be, I don't know, somewhere between there, and to be safe, I'll just do 8. And we calculate, we get our maximum. Our maximum is at 5.65, 31.87. So sorry, relative minimum. So right here, we have 5.65, 31.87, and this is our minimum. And again, we need that for our domain and our range. Or sorry, not our domain, but just for our range. All right. And then last, I want a couple more points. Easy way to get a few more points on here is go to second and then table, since we have our calculator for this one. And so I can see I have the point 4, 40, so I can label 440. I also have 632, so I could label 632. So this point here, 4, 40, and then 632. There's my 632. It's not really drawn that well, but it's off the graph, so it's kind of hard for me to do that. All right, so now I have it graphed, everything's plotted, unless I need to just find the domain, and then I need to find the range. So my domain is going to be everything except for the vertical asymptote. So I have, let's see, I'll write this one in interval notation. So I'm going to go from -infinity to 3 union 3 to infinity. And for my range, I'm starting from -infinity all the way up to, going all the way up to here. So from -infinity to the y coordinate, so 0.13 to 0.13, union, and then I'm starting again at this minimum value right here and then going up. So I'm at 31.87 to infinity. And there's my range. Whenever you have slant asymptotes, you're welcome to use your calculator for the domain and range. I think sometimes I forget to write that on the assignment list, but please do use your calculator to find the relative max and min so that you can get the accurate domain and range value as needed. All right, let's continue on. And the last one that we're going to do together is example number 9. So in example number 9, you can see here that we have our two asymptotes that we have already found. And those asymptotes that we already found are not the correct ones. I was looking at the wrong problem. So x squared, let's see here. All right, I realized that I put this on the wrong graph. We actually want to do example number 10. You guys are going to do number 9 on your own. So jumping to number 10. This is the one. We have our vertical asymptotes are plus and minus square root of 2. And then our horizontal asymptote is our slant asymptote is y equals 1/3 x. And we found that by doing our long division because our numerator degree is exactly one more than our denominator's degree. So we start with all of this on our graph. And now we want to find the rest of the information. So we're going to go ahead and we're going to find our x-intercept and our y-intercept. So you can go ahead and plug in 0 for the y and then 0 for the x. And we get our x and our y-intercepts. You should have that your x-intercept is 0, 0, and your y-intercept is also going to be 0, 0. All right, so we have a point here at 0, 0. Notice that that is going to cross this slant asymptote. And it's okay to cross a slant or a horizontal asymptote, but it's not okay to cross a vertical asymptote. Okay, so it's okay to cross a slant or a horizontal, but it's not okay to cross a vertical. All right, and so now we're going to continue on and we're just going to find the rest of our points to our graph. So finding the rest of our points to our graph, we're just going to plug in numbers. So we need to plug in numbers to the left, we need to plug in numbers in the middle, we need to plug in numbers to the right. Now, before I plug in numbers, though, I want you guys to notice something. And this isn't something that you need to write down, but it's something that you should be thinking about. We know a lot about functions. And one of the things that we know is we know about symmetry when it comes to even versus odd. And so this function here, let's think about if it's even or if it's odd. So in order to be even, we know that it would have y-axis symmetry. And we would know that f of x is equal to f of negative x. So if I plug f of negative x in there, you can just do it in your head. That's not going to work out. So it's not even. Okay. If it were odd, then I know that it's going to have origin symmetry. And I would know that f of negative x is going to equal negative f of x. And so I plug that in my head. I can see that f of negative x does equal negative f of x. And so I can use this fact of our origin symmetry for our odd functions to find additional points. So as I'm plugging numbers in to find points, then I can use the symmetric point over the origin. So let's go ahead and find a value. So if I start with, let's say 2. So if I calculate f of 2, I'm going to get 2 cubed over 3 times 2 squared minus 6. And when I calculate that, I get 4/3 when I simplify it. So f of 2 is 4/3. Similarly, I know that f of negative 2 is going to be the opposite of that, negative 4/3. So I have the point 2, 4/3. And then I've also found another point, negative 2, negative 4/3. So you can use your knowledge of previous concepts so that you don't have to do double duty and plug in as many numbers. If I plug in a 3, f of 3, when I calculate f of 3, I end up with 9/7. f of 3 is 9/7, a little bit above there. So 3, 9/7, which means the opposite of 3 is negative 3 is going to be negative 9/7. All right. And then I want to find one more that's on those outside branches. So let's see, what if I calculated for 4? If I calculate for 4, you should get 4, 32 over 21. So 4, 32 over 21. And then similarly, negative 4. It's hard with my asymptote so close. Negative 4, negative 32 over 21. So I can get these branches drawn in to go like so. And then this branch can go like so. So you can always find more points and find them so that they land on the graph. And then in the middle, you can calculate points if you calculate positive 1. If I calculate positive 1, I get, let's see, 1 over 3 minus 6. So negative 1/3. So 1 negative 1/3. 1 negative 1/3, which means I have negative 1 positive 1/3 using my symmetry. And I can make my graph like so. All right, that's the end of today's lesson. We have to do our domain and range. So domain and range is everything except for the asymptotes for the domain, everything but the vertical asymptotes. So I have here x such that x cannot equal plus or minus root 2. Now for my range is interesting on this one. My range is actually all real numbers because we do cross that slant asymptote. And so I have all real numbers for my range because every single y value takes on some place on the graph. All right, that's the end of part B. So I would like you guys to go back and finish the rest of the examples from this lesson packet.